Now the second thing that's in 4.3, which kind of feels like it's out of the blue, is piecewise defined functions. So I've written a little bit here, and I'll just kind of read through it with you guys and expand on it a little bit. If you want to have a function that behaves differently on different intervals, you might want to use a piecewise function. So when would you want to use this? Seasonal sales of things. So like in December, no one's really buying lawnmowers, right? So, you know, lawnmower sales would be, you know, low, right? But once it hits April and even May, lots of people want to start buying lawnmowers because they're mowing their lawn. So, you know, the slope perhaps on, you know, say August to April is small, say 1, but the slope from April to August, when it's summertime and everyone's mowing their lawn, maybe is large, like 5, something big. Okay, so you'd want some way to encode information in this that when it hits April, people start buying lawnmowers. Another example is like an on-off switch for something. I actually use the on-off switch a lot when I talk about piecewise functions, but an example might be energy output of a system. So if you have part of it off, then it puts out, you know, this much energy. When you flip the switch on, the energy jumps up and now it's outputting a lot more energy. So that's another example. Growth change at a certain threshold. Once your colony reaches, you say you have a bacteria colony, it's growing, and then at a certain threshold, there's too many of them and they start dying off. So at, you know, once there's 20,000 bacteria, I stop growing, they start dying. So that's examples of why we would want to use a piecewise defined function. So here's an example of a piecewise function. We join it together. So we have 3 regions. This is region 1, region 2, region 3. Now in the piecewise function, each region has its own behavior, and then each region has the definition. So this column is the behavior, this column is the where. All right? So this is how it behaves. This is where it behaves like that. And then we join them together on one side with the curly brace. All right. So as long as the x value that you're plugging in is less than 4, my function looks like 3x. Once you hit 4 and up to, but not including 6, your function looks just like 4. And then if you are between 6 and 10, closed on 6, open on 10, it looks like negative x squared. So that is my function. It has 3 different versions of itself that behave depending on where you're at. This is exactly like, you know, you as a person. I have work Brittany, and I have home Brittany, and I have family Brittany, and I have friend Brittany. So even though it's all the same person, how I am at work is different than how I am with my friends, right? Or how I am with my friends is even different than how I am with my family. So same function, one Brittany, 3 different types of behavior depending on where you're located. All right, so that's the idea behind piecewise functions. Real quick, I do want to show you what this looks like. So in actually, I'm going to use Desmos to show you guys this. Hopefully this shows up okay. So this is 3x for x less than 4. And it's 4 for 4 less than or equal to x less than 6. And then it's negative x squared for 6 less than or equal to x less than 10. Okay. And I'm going to need to zoom out. I should have picked a different number, but here's what I have. Let me, here we go. Okay, so I've got a part that is linear, positive slope, then it changes to constant, and then it changes to a negative parabola. And it's not so easy to tell, but that this, this is not linear. This is growing, with a exponential, okay? And we are going to talk about how to graph these. First, let's just look at evaluating them. Okay, so evaluating piecewise. My suggestion is figure out the region, and then you use that definition. So evaluate at the given points. So for A, let's do, I don't know, F at 0. So F at 0. When I see this, I want to go through my list of regions 1, 2, and 3 and figure out which region I'm in. Because this thing, so this 3x, if I'm any x value less than 4, then my function equals 3x. It doesn't care about these other things because it's only this linear stuff, right? It's only that. The f of x doesn't know about these other pieces until they're turned on. And only one piece is on at a given time. All right, so at f at 0, maybe what you'd want to write is x equals 0, which means I want region 1 because 0 is less than 4. So that's the region I have to be in. So that means the 3x behavior is turned on. So 3 times 0 equals 3. So that's your answer, 3. That means the point, remember functions and points and graphs and in and out, in went 0. Sorry, 3 times 0 is 0, not 3. Blup, blup. Okay. Try again. 3 times 0 is 0. Okay, so in came 0, out came 0. So the point 0, 0 would be on my graph. And if we look, oh, look at that. 0, 0, it's on the graph, just like we wanted to see. All right, so for B, let's do F at 7. F at 7. Same thing. What's your x value here? Your x value is 7. Okay, so x equals 7, which means which region do I need? Is 7 less than 4? No. Is 7 between 4 and 6? No. Is 7 between 6 and 10? Yes. So I want region 3 because 7 is between 6 and 10. So that means my function has the quadratic part turned on. It's not linear, it's not the constant, it's just the quadratic. So I plug in 7 to this definition. So negative 7 squared, which is negative 49. So in went 7, out came negative 49. So if I go to my graph, I should see that with my graph. So let me actually just plot the point. 749. Oh, sorry, negative 49. There it is. Okay, so 7, negative 49 does lie on the graph of my piecewise function, just like we wanted to see. All right, so let's do a couple more. By the way, this, and also the x, or the square root of x that I was talking about in the library functions, but this is an example of why the arrows are important. This goes on forever and ever and ever, any x value. So if you think of the interval, it's negative infinity to 4. This one stops though, right, at 10. So I would have an arrow on part of it, but not on the other part. Okay, so let's do another example. Let's do C. Let's do f of 5.1. F at 5.1. So again, regions 1, 2, or 3. So here the x that I'm plugging in is 5.1. So what region are we going to want to use? I'm going to flip back real quick. It's unfortunate that I had to switch pages. So here's my f. 5.1. Is 5.1 less than 4? No. Is 5.1 between 4 and 6? Yes. So I'm in region 2. Also 5.1 is not between 6 and 10. So I'm not going to be using region 3. So region 2. So I would write region 2 because 4 is less than or equal to 5.1 is less than 6. All right. So that means my function is behaving like region 2. Region 2 says that f equals 4. It's independent of your x choice. So your answer is just 4. So in goes 5.1, out comes 4, which means that the point 5.1, comma 4 should be on our graph, which it is, right? Right here. It's my little constant part. All right, so let's do D. For D, let's do f of, oh, let's get rid of that, sorry. Let's do f at 10. All right, so in my machine, I'm plugging in the number 10. So that's what I need to know what the machine does with it. So when I plug in 5.1, my machine is just always going to spit out 4. When I plugged in 7, my machine spits out the negative square. When I plug in 0, my machine spits out 3 times that number. All right, so this one, 10. One more time, I'm going to flip right back. So I have to figure out what region I'm in. The regions were less than 4, less than 4, between 4 and 6, and between 6 and 10. So not less than 4, not between 4 and 6, possibly between 6 and 10, but here's a problem. I have x has to be strictly less than 10. So it actually cannot be in region 3. So it's not in region 1, 2, or 3. So there is no definition for f at 10. So there is no corresponding region. All right, so this is undefined. So if I plug in anything 10 or larger into my function, into my machine doesn't know what to do with it. So this is undefined, and that would be your answer for it. If you go to your graph, so in goes 10, out comes nothing, right? In goes 10, there's nothing on my graph. There's nothing put there. All right. So evaluating piecewise functions, write what your x value is, figure out which region you're in, then you evaluate at just that region. You don't do you don't plug x into each piece, only the piece that it's defined on.